Welcome to AI Paper Slop. We are jumping straight into a new paper today called COLLEAGUE.SKILL, Automated AI Skill Generation via Expert Knowledge Distillation.
Right, and this is by Tianyi Zhu, Dongri Liu, and the team over the Shanghai AI Lab.
And we want to give you the core insight of this deep dive right up front.
Yeah, so essentially this paper solves a massive problem in our field right now, which is how we transfer highly specific human expertise into large language model agents.
Because right now, the way we do it is, well, pretty messy.
It's incredibly messy. If you want an agent to act like your lead developer today, you are probably relying on these massive monolithic system prompts, right?
Or just unbounded behavioral cloning, which is a nightmare to control.
Exactly. So Colleague.SKILL replaces that entire paradigm. They built an end-to-end pipeline that takes heterogeneous traces, so things like chat logs, pull request reviews, incident docs, and distills them into a governable skill package.
And the really crucial part here is that it explicitly separates a person's capability from their communication tone.
Yes, that split is everything. It outputs this schema-compliant artifact that your agent frameworks can just dynamically load whenever they need it.
Which brings us to why this actually matters for you, especially if you're an engineer building these systems. The stakes couldn't be higher right now.
Oh, absolutely. We're in the middle of this massive shift from single prompt, one-off conversational assistance to complex agentic workflow.
Like we're building systems that run in the background, making actual decisions.
Yeah, and when you deploy an agent into a production environment, you need a standard way to package that domain knowledge. You don't just want an agent that accurately mimics a person's typing quirks or like their emoji usage.
You need a system that safely executes their highly specific decision heuristics, and it has to do it without hallucinating.
Exactly. So to understand why this new pipeline is such a necessary evolution, we really have to look at why our current persona and memory systems completely fail in enterprise environments.
They really do just fall apart, don't they?
They do. Because the fundamental flaw is how we've been modeling actionable human knowledge. Expertise just isn't written in a clean linear instruction manual.
Right. Nobody sits down and writes a document titled My Complete Mental Model for Reviewing Infrastructure. They just do the work.
Exactly. A senior developer's actual working logic is deeply scattered. You might find this brilliant heuristic about, say, database sharding buried in some old code review from 2 years ago.
Or their standard for API rate limiting is just hidden inside a random Slack thread where they rejected a library.
Yes, and the researchers classify all of these scattered artifacts as heterogeneous traces.
Which makes sense. They are traces left behind by the work.
Right. But when current agent frameworks try to ingest that reality, they usually default to brute force. They either dump all of those raw traces into a hidden vector database for RGA, or
they just attempt to compress everything into one massive system prompt, which is just asking for trouble.
It really is. The paper refers to the fallout of this as unpredictable impersonation.
Unpredictable impersonation. I love that term.
It's so accurate, though. An agent built this way might perfectly capture the developer's habit of signing off with a thumbs up emoji, but then completely miss their rigorous standard for input validation.
Because the underlying model suffers from attention dilution when you just throw everything into a single prompt space, right?
Precisely. It struggles to distinguish between a strict factual standard, like, always check authentication headers, and a behavioral quirk.
It's basically conflating an impression with actual expertise.
Yes, and that conflation is exactly what leads to brittle, untrustworthy agents. When the model tries to balance sounding like a specific person with executing a complex task, the task performance degrades.
Because the behavioral constraints are actively fighting with the logic constraints for the model's attention.
That's exactly what's happening under the hood.
It's the difference between asking an AI to do a funny impression of our lead engineer versus handing the AI the lead engineer's exact ATI review checklist and telling it to apply those specific rules.
That's a perfect analogy.
Because if I am setting up an automated PR review pipeline, I do not care if the agent sounds exactly like my coworker. I care that it flags the same rate-limiting vulnerabilities my coworker would flag.
Right. And the architecture of Colleague.SKILL prevents that conflation by splitting the distillation process straight down the middle.
So this is their solution, the dual-track distillation.
Yeah, the researchers developed this dual-track representation. So instead of generating a single tangled persona file from those normalized traces, the pipeline runs two distinct parallel extraction tracks.
Okay, so what's the first track?
The first is the capability track. This pass is entirely focused on extracting durable work methods, explicit expert heuristics, and mental models.
And it compiles these into a specific file, right?
Yeah, it saves it as a file specifically named work.md. This essentially becomes the pure how-to logic of the job, stripped of any conversational baggage.
Okay, and then the second track.
Then the pipeline runs a secondary behavior track. This pass extracts expression style, communication constraints, interaction boundaries, and it saves all of that into a separate persona.md file.
Okay, wait, I have to push back on the separation a little bit, though.
Go for it.
Isn't someone's communication style inextricably linked to how they work? Like, if you look at code review, the way you deliver feedback, your tone, your strictness, whether you ask leading questions versus giving direct commands, that's a core part of that expertise.
Yeah.
So splitting them feels like you might lose the nuance of how that person actually operates inside a real team.
That nuance is absolutely vital, which is why the separation happens at the file level rather than the framework level.
Oh,
By splitting them into two files, you prevent the underlying model from confusing a stylistic flourish with a factual rule during inference. The magic here is control.
Right, because now you can choose which one to use.
Exactly. It allows agent frameworks to invoke a capability-only entry point when style transfer is inappropriate.
So if you have an agent running a silent background security check based on a senior engineer's heuristics, you only want the logic from work.md applied.
You definitely do not want the output wrapped in conversational pleasantries, because another software system might need to parse that output.
That makes total sense. You retain the full artifact, but you gain the ability to dial the indication mode to full simulation, work only, or persona only, depending on the context.
Which is incredibly powerful for enterprise use cases.
Which brings us to how this actually gets implemented, because once this knowledge is split and extracted, it needs a standardized format, right?
Yeah, you can't just hand a raw folder of markdown text to a framework like Claude Code or OpenClaw and expect it to manage context windows efficiently.
No, that would just blow up the context window immediately.
Right, so the system utilizes an artifact writer to generate a highly structured package based on their Schema v3.
Schema v3, so what does that package actually look like?
The entire package is centered around a skill.md file, which is heavily supported by two JSON files, a manifest.json and a meta.json.
And the JSON files are what make this executable, rather than just readable by a human.
Exactly. The manifest.json maps out the installation data, the specific entry points for the capability and behavior tracks, the compatible runtimes, and the / commands.
So it tells the system how to actually run the skill. What about the meta.json?
The meta.json handles the lifecycle tools. So things like schema versioning, data provenance, and correction counts.
Which directly aligns with the emerging agent skills standard.
It does. And by separating the metadata from the actual heuristic instructions, the researchers enable this concept of progressive disclosure.
I love the progressive disclosure mechanic because it operates exactly like a software library dependency in traditional coding.
Yeah, explain how you mean that.
Well, when you write an import statement at the top of a Python script, you aren't loading the entire library into memory right then and there. You only pull what you need when you actually call a specific function.
Right, it's lazy loading.
Exactly. And in this architecture, the agent framework only sees the metadata first. The agent is aware that this skill exists and knows what it is capable of based on the manifest.
But it doesn't load the massive instruction sets from Part A for capability or Part B for behavior until the skill is explicitly invoked.
Right. And the token economics of that approach are massive.
Oh, huge. Instead of paying the compute and context cost to load 50 different expert personas into your agent's memory at startup, the agent dynamically swaps them in and out.
It preserves the model's reasoning space for the actual task?
Precisely. But, treating human expertise as a software dependency introduces a huge operational challenge. Debugging, exactly. Because no AI extraction pipeline is perfect on the first pass. Creating the structured package is just the initial step.
The real test is how the system handles the inevitable moments when the agent misapplies a heuristic.
Right. Because if you were dealing with a massive monolithic prompt, debugging would be a complete nightmare.
Oh, it's the worst. You would try to tweak one sentence about input validation, cross your fingers, and just hope you didn't accidentally overwrite the agent's instructions for database queries.
It's incredibly fragile. It's like playing Jenga with prompts. But COLLEAGUE.SKILL treats behavioral feedback as version-controlled state.
Which is so cool.
They built a dedicated correction lifecycle that essentially acts like Git version control, but for human judgment.
Okay, so Break down how that update loop actually works.
It's elegantly separated based on the tracks we discussed earlier. So imagine you are interacting with a generated colleague skill, and it provides a code review comment.
Okay.
And you give natural language feedback, like, no, she wouldn't just approve this. She would push back on the input validation logic here.
So you're just talking to it naturally.
Yeah. And the system parses your feedback and routes it appropriately. Because this is a capability error, it doesn't try to rewrite the entire prompt.
Thanks goodness.
Instead, the pipeline generates a specific markdown patch that targets and replaces only the section in work.md related to input validation.
It acts like a synthetic pull request on the agent's explicit memory state.
That's exactly what it is. And if the error is on the behavioral side, say the agent uses too much corporate jargon when the real person is normally very blunt, the system routes that to the behavior track.
Okay, so it patches the persona.md file.
Sort of, but it generates a normalized correction record first. It logs a JSON object with 3 explicit fields: seen, wrong, and correct.
Oh, wow.
Yeah, it literally maps out, in this specific context, you use this incorrect jargon, you should have used this blunt phrasing instead.
So it's building a data set of corrections.
Exactly. Creating normalized data structures for behavioral corrections prevents the model from drifting over time.
So once the patch or the correction record is generated, what happens?
The artifact writer steps back in. It increments the schema version number, archives the old state, and regenerates the derived files. The agent seamlessly hot swaps to version 2.
The ability to roll back an agent to yesterday's personality or logic state is revolutionary for machine learning engineers.
It really is a game changer.
Taking the black box of an AI persona and turning it into an auditable, diffable, versioned artifact, it brings rigorous software engineering principles to what used to be a very messy prompt engineering process.
Absolutely.
Yeah.
And, while the colleague setting we've been discussing is the most controllable and useful for enterprise environments, the researchers also proved the flexibility of this artifact contract by applying it to completely different domains.
Right. They introduced 3 distinct domain presets in the paper.
Yeah. The colleague preset, the celebrity preset, and the relationship preset.
So the colleague preset makes sense. That relies on enterprise traces and organizational governance, making it highly structured. But the celebrity preset is fascinating.
Yeah, the public figure preset operates very differently. It utilizes a specialized research pass over public interviews, speeches, and published writings.
But the most important feature of the celebrity preset is the strict citation discipline built directly into its governance rules.
That is the key, yeah. Which means the agent actually has to cite its sources for a mental model.
So if you ask a public figure skill a question about a highly specific topic they've never publicly discussed, what happens?
Well, the agent is constrained by the evidence limits defined in its persona, a.md and work.md. It will actually refuse the private inference rather than hallucinating what that person might think.
That's incredible. It forces the artifact to remain a research-oriented tool with clearly visible boundaries.
Exactly. It's not pretending to be them. It's just synthesizing what they've actually said.
But then there's the third preset, the relationship preset.
Yeah.
And this one brings up a completely different set of governance challenges because it is built on private interpersonal traces. I mean, the red flags here are obvious, right? Non-consensual simulation, emotional overattachment.
Oh, absolutely. Building a preset on private text messages or personal emails demands a completely different technical architecture for safety.
How do the researchers justify even building this?
Well, the paper explicitly does not frame the relationship preset as an endorsement of unconstrained widespread use.
Okay, good.
It isn't a manual for building digital clones of your friends. Instead, it serves as a rigorous stress test for the artifact's governance controls.
Ah, I see. Because in an enterprise setting, governance is relatively straightforward. The company owns the data and the infrastructure.
Right. But in a private setting, the technical system itself has to enforce privacy and local control.
And the researchers demonstrate that by treating the skill as a highly structured package, they can embed governance directly into the metadata.
Exactly. The JSON schema physically contains fields that enforce non-public defaults. Compatible agent runtimes will literally refuse to execute or upload the artifact if it detects it being moved to a shared remote server.
That's a huge shift. It turns concepts like verifiable consent and local deletion paths into first-order artifact requirements rather than just relying on a user's good behavior.
Right. Because if we are moving toward person-grounded AI, it has to be an editable, locally deletable artifact that you fully own.
So to prove that treating skills as governed, installable packages actually works in a real-world ecosystem, the researchers didn't just write a paper, they open-sourced the entire pipeline.
They did. They built a public deployment surface, including a repository and a community gallery. And the metrics from that release highlight a major shift in how developers want to interact with agents.
Looking at the stats from May 2026, the public repository gathered approximately 18,500 GitHub stars.
Which is massive.
It is. And the public gallery hosted 215 generated skills from 165 different community contributors, pulling in over 100,000 cumulative gallery stars across those listed skill cards.
That is incredibly rapid traction for a completely new artifact format.
But we do need to highlight a crucial caveat straight from the researchers regarding those numbers.
Yes, very important. The paper explicitly states that these metrics do not prove behavioral fidelity or task performance.
Right. A high star count on a gallery card does not mean the agent flawlessly executes a code-based review or perfectly mimics a target individual.
Not at all. What the data actually proves is the viability of the distribution surface itself.
It proves that you, as an engineer, actively want to install, share, and version control person-grounded skills across your local hosts.
Yes. This completely transitions the concept of agent personas from weird private prompt packs that live in a single developer's notepad
Into an open-source, shareable marketplace of expertise.
Exactly. You can go to a gallery, find a security architecture review skill grounded in a known expert's public writings, download the package, inspect the work.md file to see the exact heuristics being used, and plug it directly into Claude Code.
And if that skill hallucinates a step in your local environment, you just patch the work.md file, increment your version, and continue working.
It transforms expertise from an abstract concept into a tangible, iterated software dependency.
That is so cool. Let's synthesize the paradigm shift here for you. The future of agents isn't about open-ended, unbounded impersonation.
No, we are moving way past the era of trying to build chatbots that simply sound human.
The future is built on bounded, explicitly governable skill packages. It is about isolating a capability from a behavior, exposing the limits of the evidence, and relying on inspectable correction loops.
It provides a necessary schema for the messiness of human knowledge. By standardizing how we extract and store heuristics, we can finally integrate human judgment into automated pipelines with the exact same rigor we apply to traditional code.
Which brings up a fascinating thought to leave you with today. If we can successfully distill version control and share a senior developer's review heuristics and mental models as an installable package, what happens to the concept of organizational knowledge when the line between an engineer's written documentation and their automated, executable digital double completely disappears?
Wow, that's a huge question.
It's definitely something to mull over the next time you review a pull request. Thanks for joining us on this deep dive into the source material for AI Paper Slop. We'll catch you on the next one.